Alright, this is going to be talking about the formal lab reports and talking about the results of the formal lab report 1 and then talking about formal lab report 2, which will be due the first Monday of the finals week. So, the beginning of finals week. That one really can't be late. It has to be in by Tuesday morning of finals week because I need time to grade them. And the grades are actually due on the Monday following finals week. So I literally won't have time to grade these if you guys just, give them to me Wednesday, Thursday, Friday, or something. That's not going to work out at all. So you have to submit it early or make sure you're absolutely sure there is no problems ever at all getting them in Monday. Monday is you don't get it any grade for it if it's not to me by Tuesday morning when I start grading. So the formal lab report, you got partial credit if you did the sections period that you were supposed to do, and you actually made a reasonable attempt at them and just didn't put in random material to fill the space. So if you follow the directions, you got partial credit. And you actually got fairly generous partial credit in several of the sections, like a third of the credit just for putting something in the introduction that's even close to an introduction at all. Any history, anything. Abstract, you usually got some points just for doing an abstract period. However, a number of you did not do things like that. There's people that didn't put entire sections in the paper. References and abstract being the two big ones that the most people forgot those sections. Though some of them didn't put any discussion or conclusion. Some of you didn't put some of these sections. Anyways, so what you'll notice if you look at the grades for these, you may have already realized that if you looked at the assignments before. This one's worth 100 points, this one's worth 200 points. They'll be graded fairly similarly, though there is a accuracy portion to this formal lab report number 2. So that what that means is that you lose less points for the first one, which a lot of more people have trouble with. The second one, usually more people do better on because they realize they need to actually put in some work on it. Okay, let's go ahead and go over this a bit. I'm going to use this, which is an actual publication. Your lab report doesn't need to look exactly like this, first off, because it's professionally formatted. But the other part of this being that yours won't be anywhere near as long. You can, of course, read the guidelines right here. Those would tell you how to do this, but I'm going to go over it one more time because apparently many people didn't actually read through those. Okay, so you have your title, of course, experiment, and then write out the title. And that's the best way to do that. You put your authors. If you worked with anybody else on the experiment, you would have to put them in there, but you're always going to be the first author because you're the one submitting this. This is your abstract. Your abstract should be a very short statement of what you did. Essentially, I made this and then tested for presence and purity. Then it should go into something along the lines of just a very small amount of the data that would support that conclusion, and any important constants or any important numbers that you would have gotten. So, for example, you guys would have your percent yield, should be in your abstract. It should also be in your results. But your percent yield should definitely be in your abstract and results. You should have important bands that you assign for the infrared, if you did infrared, which you're doing for both of these assignments, and so you need to mention them. You should have your melting points in here and a comparison melting point, literature melting point in your abstract. And it should be a very short statement. The abstract for you guys should be shorter than this because this is a 30-something page publication. In fact, if it was when it was formatted like your guys' publication, it's actually closer to a 60-page publication. This is a much more condensed formatting. Notice these paragraph things here would actually be almost entire pages. So like this right here would be 2-3 pages if it was in your guys' publication. Anyways, okay, so, and keep in mind when you do this writing that you shouldn't have opinion. You should state things in opinion neutral ways. That you're trying to build a case and support it with data. Specifically, you're actually trying to disprove things and you're stating what you're left with. But things like the true product, the real product, those aren't statements that you should make. You should make statements like the product that was supported by the data, or the literature value for the melting point, that sort of thing. It's not the true melting point. Science doesn't do truth. That's a metaphysical concept. That's philosophy or religion. So your introduction essentially, well, first off, one of the big things is you gotta structure the paper. Papers need structure so I can actually read these things. If you submit a page and 2 pages where you don't have any paragraphs at all, it's literally just one big paragraph, mostly run-on sentences, and I can't find anything, so you haven't separated your ideas at all, you're of course going to get a bad grade because you're making absolutely no effort to communicate with me. You're essentially dumping out information in the hopes that you get some sort of points somewhere. You gotta structure these things. Take time to structure them. Take time to actually think through what you're gonna write here. Don't just vomit on the paper, okay? And hope that something sticks. All right. So the introduction should have a lead-in. The lead-in is something interesting. So it'd either be a reaction pathway and how that is involved with some sort of process that you'd actually care about. Like, this is used to synthesize these sort of drugs that are used for these purposes. Or the compound, which is used, this is used to make plastic. This is used to do something, right? So connect the world to your publication. That's the first part of the paper. And then the next part of the paper should be a literature history of the subject. So if you do a really good job like these publication right here or a dissertation would, you would exhaustively cover your topic's literature history. And so if anybody wanted the literature history of that compound, in this case, on this paper right here, or in the case of your guys' it's a type of reaction and or a compound. It's a little bit of both. I'm not expecting an exhaustive literature history. I'm expecting at least a solid effort, an undergraduate level effort. This would obviously be a professional level effort. First off, it should of course have references. You need to do more research than literally just look in your textbook, or as some people have done, nothing. Literally nothing. Just throw together stuff from your lab notebook. You can't just write a paper from your lab textbook and lab notebook, lab notebook. This is a formal lab report. This is most your grade for this. This is a publication. This is a paper you're submitting. You can't just throw together stuff off the top of your head. You need to investigate and get some sort of history and have some sort of references. So the introduction should definitely have references that are located in your references and which you designate. You can do it in a standard formatting. I don't really care what type of formatting you do. So most of you did like author year, and then there was author year at the bottom. I personally prefer the numbering system. Most scientific publications do that. But whatever, I don't really care about the formatting of the references as long as it's standardized. The big thing is this has to be a literature history. You have to actually put in some work and effort into this. If you're throwing this together the night of, you should not expect to get a passing grade. Okay? This is the paper. This is why you have time off. This is why there's breaks in the system. It's supposed to give you extra time to be able to do this. And really, I've said this on multiple occasions, you should be starting the history literature research before you ever finish the lab. I said that 3 times in the previous one. So this one right here, then finally in your introduction, you should essentially just say what you're going to do. A very short what you're going to do. So we're going to synthesize the compound, take a spectra, and take a melting point. There you go. What you should not do, and definitely not do, is, and a few people did, and it's a common problem, don't feel bad, but you gotta not do it, is essentially take your materials and methods and regurgitate them in every section of the paper, the same thing over and over and over, with slightly different wording. Don't try to throw in information in here and just throw stuff in and hope something sticks, because you're going to get graded down for it and it's not going to work with me. Okay? I actually used to edit papers, these sort of scientific journal papers, and I've been the editor or reviewer for, the editor, I've been an editor on, probably 3,000 publications. So 3,000 of these articles. As a reviewer, I've been a reviewer on over 1,000 publications. So I can make my way through these. They just take me time. If I have to spend all night grading these, I'm not going to be particularly happy with it. But you'll get the same grade, which is you threw shit in here. It wasn't needed. It wasn't something that was supposed to be in here. You didn't follow the directions. You're going to get points off. Okay? All right. So the next thing is the materials and methods. If you follow the directions, is what you should actually put on here. This is a much longer publication, so the materials and methods is actually split up and is just vastly more materials and methods than you guys would need. So a materials and methods section, this is where you'd put your procedure, though you shouldn't actually put your measurements in your materials and methods in this part of in the text of the materials and methods. It should literally be your procedure as you would want the person to do so. The results is where you actually put your measurements. And you can actually reference tables here. So like I took the infrared. If you would like, you can put your infrared spectra here. But you can also put in your results when you're going to talk about it. In publications, typically you would put your spectra, the actual data you obtained, you would put it towards the end of the materials and methods section. You would reference it there, and then you would use it in your results. But keep in mind, this is not the results section. There should not be results in materials and methods. There's literally a section called results. That's where your results go. It's, pretty clearly labeled there. And you definitely should not make any conclusions here. Saying things like, I obtained the product, or I did not obtain the product. This is not what you should do here. And this is also not where you particularly want to point out that I spilled something or any of those things. That would actually go in your conclusion. So the next part would be your results. This paper actually has a bunch of results sections, and that's because this paper has multiple things going on. This is a full publication. This is not an undergraduate paper. I just wanted you guys to actually see what those look like, so you see why you're doing what you're doing. So your results section should literally be your results. So I got this. This is my weight. And I use my calculation. You just put your calculation. And this is my percent yield here. And it should just be a straightforward, this is what I got, and this is the calculation, and this is the derived value I got from it. For an undergraduate report, some of you put in a table of frequencies and their assignments. And for an undergraduate report, that's actually probably a smart idea. Because I noticed a lot of you were misassigning things because you probably didn't look up a table and you tried to do it off memory. So yeah, that's actually a good idea, an undergraduate report. That's cute. I liked it. It was probably a smart idea, actually. But in a normal publication out in the world, you would not want to put something like that. You would want to reference assignments. If it's widely spread information like frequency assignments, you don't have to reference it at all because it's public knowledge. Anyways, so again, your results is literally the result of your experiments, the weights you got, the spectra you got, the melting point, which is a range, remember that? So it should be a temperature dash temperature. And then you would finally have in your results you would put next to those your literature values that you're going to want to compare with, okay? You don't actually have to put your literature values that you want to compare with in your results. You could come in your conclusions instead. But I believe it's easier if you just go ahead and put the melting point you got. The literature melting point is this. The infrared spectra you got, the literature infrared spectra, and then go and follow them with this band right here, this band right here, this band right here. These match these bands in my literature spectra, and from my literature spectra and my these bands from my experimental spectra match these bands and the literature spectra, and these are the functional groups that they are typically associated with. That would be fine to put in your results. However, they may be, I'm not going to grade you down either way. If you put those in results, if you put those in conclusions, it's okay. They probably would be better placed in the conclusion, and you just go ahead and put your actual results in results to be more clear, hopefully. So when you do your conclusion should be, I synthesized this product. I believe the product is such and such, and then these are the proof that I'm going to use to build my case. And so those would be the things like well, I got a melting point of this. It's very close to the literature value, which is this. That gives me some evidence. These peaks are in my infrared spectra. They are the CO stretch. They are the CH stretches. They are the CH bends. They have the same pattern as the publication spectra, the literature spectra. And so I very likely am the same compound as the literature spectra. Or it could be the reverse. I don't really care if you actually get the actual compound. I'm more concerned with you actually being able to reason and talk. You'll get very little off if you go ahead and reason this out and tell me, yeah, I don't have the same spectrum. I have something else. And if you don't know what it is and you can't figure out what it is, usually the substrate, by the way, um, then just say, I don't know what it is, but these are the functional groups it seems to have. Don't try to bullshit me. Don't try to lie to me. Don't try to sugarcoat it. It's not going to help you out. I'm going to fairly trivially see through any of that. And you're going to get some points off because it's inaccurate. And if you just outright try to lie to me, then you're going to get a lot of points off, actually. Because that can't be tolerated. That's what cannot be tolerated in science at all, is trying to forge data, trying to misreport. Okay. Anyway, so your conclusion is literally you're building a case. Did I get this product, and how much of it did I get in these papers? Okay. You can do a little conclusion part at the end that's like, these are things I would like to see or do in the future. These are other tests that would be interesting. This is interesting because, and if you do things like spill, if you have problems, if you have an issue, this is also where you'd report it in your conclusion. But for a paper, the papers you guys write, your papers are just not long enough to have a discussion and conclusion. I didn't take any points off if you did it. It's fine. I'm okay with that. But the reason that a paper like this has a discussion and conclusion, look how long the discussion is, because there's so much data to discuss. So you need a conclusion at the end to recap, because once people get to the end of the discussion, they're not going to remember what they started with. There's just too much of it. You guys don't need that. You'll be fine. Your discussion should not be that long. It actually should be quite short. And if you want to call it your conclusion, that's fine too. You don't need a separate discussion conclusion like this paper would have. Right. So references, you should do a standardized references on your paper. You should use the references. If you haven't used the reference at all, there's something very, very wrong. Either you did not need it, or you've done something very wrong. For example, your procedure should actually have a reference of your textbook. The textbook gave you a procedure. You took that procedure from your textbook. You didn't come up with it. So technically, there's quite a few of you actually who plagiarized, because you took your procedure, you did not give any sort of indication that you took it from a text, and then you didn't reference it all. So that is actually plagiarism. If you were to do that in a publication, you would actually have some problems. Like if you were to publish that as a book or something, you would get sued. Okay? Or if you put it in as an article, you'd have issues. Anyways, I didn't take any points off for that because I understand why people did it. I get it. You guys are so far removed by the time you do the lab and do these reports from the textbook that many of you probably didn't even think about it. You should have more references than your textbook, okay? And you do not need to reference yourself ever, because your lab notebook, because this is the formal reporting of that lab notebook. That's literally like referencing this paper itself inside the paper. That it doesn't make any sense. So you should have more than your lab textbook. However, I can't give you an exact number of references you need. That just doesn't make any sense. For example, if you do really well, some of these things have review articles, which would cover everything you guys need, period. And you wouldn't need it. You would literally be able to do this with 2 or 3 references. Okay? If you find a good enough article, you could do it with 2 references, but I would be surprised. Most of you could find like 3 to 5 references, including your textbook for the lab, and possibly your textbook for the lecture if there's something interesting in it that you want to use. But frankly speaking, if it's less than 3, there's no way that you did this. You didn't. Then you don't have any history, literature search at all. I know you didn't do it at all. However, Most of you should have probably more than 5, because you're going to need a few references for the literature history. That properly done literature history should have a few references, unless you get very lucky finding a very complete article on it, which would be surprising. All right, so that should probably about cover it. You really do need to put some actual work in these things. This is not throw it together in an hour or two. This is do the search, literature search, get a good history going, put together a rough draft, format that, make sure you have all the sections in it, cut stuff where it doesn't need to be, make sure that you have all your calculations, your tables, do a good job with the infrared assignment with the functional groups. Don't call the infrared spectra an NMR spectra. Make sure you're accurate in the groups where you quote them. Don't just try to pull it from memory. It's a bad idea if you're trying to put in something that's worth so much of your grade off of memory and you don't bother looking anything up. Make sure that you write out a mechanism in your introduction. You need a mechanism in your introduction. I would recommend doing it by hand, but some of you very successfully use the computer programs you have available to do it. And you can. Publications normally you would, and you'd be required to, but I understand if you guys don't want to take that time. I'm okay with you doing it by hand and taking pictures and putting those in. Make sure the pictures are actually reasonable looking. Remember, you have to communicate this to me. If I can't read it, if I can't find it, then it didn't happen, it didn't exist. You don't get any grades for it. Okay? You'll still get the points off. All right. Let me know if you have any questions. I'm going to call that good. I think I covered everything in probably more detail than you want. Don't forget to do the percent yield. I was lenient on it last time. I was lenient on a lot of things. The first one, I was more concerned with you guys getting the structure than the actual content. I'll be becoming more concerned with the content in this second one. But the first one's structure was so much of an issue that, yeah, I didn't even get a chance to really grade anything on content on a number of sections. Okay, you take care.